something that was an eye-opener for me a couple of months ago, and I wanted to share my enthusiasm with you and maybe spread that enthusiasm. A little bit of my background to keep things short is that I used to work for Google designing and building sales tools. Then I was an SRE building tooling for cold storage, mostly tools for people in data centers to scan tapes and ship them to on-prem and off-prem vaults. I also built cluster management tools at Facebook for various teams to set up provision their clusters. After that, I was briefly a CTO of a static code analysis startup that didn't quite work, although it's still alive. And recently, I founded a startup that provides a specialized continuous integration, continuous deployment platform for infrastructure as code. So if there's a common theme here, it's that I've spent most of my engineering career building things for power users. Well, you might not necessarily think about salespeople as power users, but like I can tell you that a lot of salespeople are very, very proficient in using their tools and very sophisticated users. And the rest of stuff that I've been building was for engineers. And as you probably know because you're engineers yourselves, engineers or power users, extreme power users, have very particular needs from systems that they're working with. Who can tell me what is the first thing that an engineer would want from a tool that they interface with? Ah, come on, yeah. Documentation, yeah, of course. What else? APIs, yeah. That's a good one. They want to, yeah, some sort of automation. Any other ideas? Command line interface or the ability to build one for themselves, yeah? Any other things? Because one thing comes to my mind, some sort of notifications. So webhooks is one common standard, or the ability to post to, whatever topic or whatever, maybe a Kafka stream or, I don't know, an SNS topic or SQSQ or just a plain old webhook. And they want to have a lot of options, toggles and tweaks and checkboxes and sliders to tweak things just right, because none of us really believe that the standard, settings are the best. Our settings are the best, and usually that's the case. We know what we want, and building one solution to fit all is just hopeless. But if you think about all the options, tweaks, and toggles, if you're using a traditional approach, they're a nightmare to build and maintain. And even though you can try as hard as you will, you'll never cover all the use cases. There'll always come someone who says, Marcin, have you thought about this? And I'm like, no, I haven't. Now my entire beautiful scheme is completely gone, thank you. So options, tweaks, and toggles are kind of hopeless. And just to tell you, just to give you an example, most of us probably use GitHub, and a lot of us who use GitHub use something called branch protection. And branch protection is basically a collection of prerequisites for a branch to be merged to. And this is not the whole form. There's actually way more to it, but I can give you an overview of what it could look like. So it's like, should we require pull reviews before merging the code? Should we dismiss the pull request approvals and blah, blah, blah. And it goes on forever, and it's insane. Now, we can probably deal with that. We can probably, as users, we could probably deal with that. But imagine on their database side how many fields they need just to store this logic. And once they have all those database fields, what is the decision tree to make sure that the decision that they'll ultimately come up with, whether to merge a pull request or not merge a pull request, is valid? This is just insane. And still someone will come in and say, I want to require status checks to pass unless you're an admin and one of the other admins approved your PR, but if it's outside of business hours and you're only tweaking documentation and you have linear history, that's fine, we can merge it. Well, best of luck, right? So all of that form for naught. Lesson 1 from Exhibit 1 is that GUI forms really suck at implementing complex logic. Here's another exhibit. Well, I mean, why would I need a form? I could just have a little YAML file that I check in with my code, and that would embody some of my logic. So this bit here is from CircleCI. They use YAML for configuration. And this basically says that certain steps should be executed for certain branches and not for other branches. So if I have a test build, it should be executed for all branches except for master, but deploy is only from master. So a traditional push on green approach. And that's slightly better, I'd say. What is better about it is at least you don't have to have a GUI. So it's cheaper to build. It sucks almost as much as the first approach, but it costs less to build and it's easier to tweak. But if someone comes in and says, I want to test build every branch that starts with tests and all tags that conform to semantic versioning format except for maybe the ones that start with 0, well, best of luck. I think you can do it. It's not going to be very pretty, but I think you could do it. But it's going to be like regexes on top of regexes, I suppose, very long regexes, which is pretty much programming at that point. Right. So let's try to have a different examples. We are all programmers here, so why don't we just, embed a Lua interpreter in our code and allow customers to write snippets of code that are executed. We'll just give them some input and we'll expect some of the output that conforms to what we expect, and then our app will act on this decision. Yay! This sounds ridiculous, but we just did one important thing. We decoupled decision making from decision enforcement. So the decision is made by the customer script, function, or whatever, and then our app enforces that decision. So at least our app doesn't have to have all the complex logic. But overall, is that a good idea?
No, it's not.
I did that. One example of such query transformation language would be, come on, SQL, exactly. Can you think about any other query transformation language? No, from way back before C#, from XML days, from XSLT, exactly. That's another one that actually acts on XML documents. SQL is a good one, but it acts on structured data. So what you could possibly do is maybe create a view in a database just for someone to query. That could work, why not? But if your data is loosely structured and might change more frequently, then updating the view every time you're going to allow people to write a query is going to be kind of meh. And also, queries are non-deterministic, so you never know what they're actually gonna do. And the other thing is that SQL queries can go from simple to insane in minutes, right? So ideally you want JSON support because everyone does JSON these days. XML is a thing of the past, and JSON is king these days. So if you have all of those prerequisites, there's not much choice of what you could use. Well, you could use JQ, I suppose. That would work, though it has its own problems. But I personally found something called Open Policy Agent and Rego. And I'm going to explain the difference between the two in a second. But what it does essentially is, this is a query language and query and transformation language that takes your policy and takes the input as JSON and runs some queries and returns some results. And this is all I need to implement most, if not all, customer logic. So let's take a step back and go like, wait, what a policy? What is a policy? Because we are kind of used to policies as tools for approving or denying access. And the policies, like if you've ever written an AEM policy, there's just two things the policy could do, allow or deny, right? Same with Kubernetes role-based access controls. You can log it, like you can do the thing, you can't do the thing. So a policy seems like a weird word for that, but I think what they meant is, if you look at the policy in a dictionary, it is a set of ideas of what to do in particular situation that has been agreed to officially. So there's a form of written agreement or a verbal agreement. So if in the context of your application, the official agreement is a kind of predefined query, something you kind of, yeah, that's what we're going to do. The particular situation is the document that is presented to the policy, so the input on which the policy will work. And then what to do is a constrained set of possible results. Those results might be allowed. Probably a list of groups that the person is in and maybe their level of access to those groups. And we have two possible decisions, allow or deny, which is a Boolean decision, so ultimately it's actually a one decision, because if you don't allow, you kind of deny anyway. So yeah, it's a Boolean. We can go fancy. We can actually have our policy decide a user level of access. So it's not just allow or deny, but we can say this guy can actually be an admin. So it's not just a Boolean now. We have 4 possible decisions now. Actually 3, but the 4th one is a helper. The first one is yeah, allow. The second one is no, deny. The third one would be yeah, allow, but also make him an admin, give him that admin bit. And the last one that I found useful personally, but you don't need to implement it, is deny admin. So and this is, the challenge is to have someone make configuration changes only during business hours and from the office IP. And the thinking behind it is that if things go wrong, and they could go very wrong very fast, we want that person to be available, and not only have them available, but also have them in the office so that they can use their colleagues as a backup if things just start falling apart. And we could express that as a policy. This is the policy language I'm going to be talking about. You can see that there is a number of facts that we've defined. what now means, what is the clock, what we consider to be the weekend, what is the weekday now, what is the office range, IP range, and what is the remote IP. And then we start defining rules. So the base rule is we allow them to write if they're in a product team, if in their memberships they have a product team, they can write. But we'll deny them write permissions if it's weekend, or if it's before 9 o'clock, or if it's after 5 p.m. And we'll also deny them write permissions if they're not logging in from the office IP. And this is very sophisticated logic that would probably be almost impossible to express using checkboxes or using YAML. Or you'd have to have a lot, and I mean a lot of logic on your application end to implement it. But if you externalize this problem, this becomes very natural, in fact. Once you get a gist of it, it just flows. So why would you use Rego as opposed to, I don't know, Lua or Node.js interpreter? So the reasons I can think of is it makes running customer code safe. It's not a Turing complete language. There's no loops or conditionals. So it's guaranteed to terminate, and it will ensure that queries are correct and unambiguous. As opposed to Lua, it's also declarative. So you basically, it's like with SQL, you're not telling the database engine how to get the data. You basically tell it what data you need. So it's declarative and it's easy. If you have to combine more than one Excel formula, that's almost as much as programming anyway. So this is probably the same level as Excel, whereas Lua is probably a level higher. A few words about, you'll probably see Rego mostly used by something called Open Policy Agent, and if you've used Open Policy Agent as a binary, this was designed mostly for Kubernetes and for ensuring or enforcing access policies to Kubernetes clusters, but has since evolved. So Open Policy Agent is that executable that you can have work as a Kubernetes operator or as a separate service or as a sidecar that provides an HTTP interface. But Rego is the underlying language. Open Policy Agent uses Rego, and we're not going to use Open Policy Agent. We're actually going to use a Go library that Open Policy Agent uses to implement Rego. So without further ado, I'll show you a very simple Go example. And it's a Go function that will evaluate a particular input. It's actually defined as an interface, but anything that JSON encoder can turn into JSON will be accepted. And it'll take a policy body. So it'll probably, you'll define that policy body somewhere as a file or as a database input or a field or whatever. And then the evaluation goes like this. You create a new Rego evaluator. You pass it a query. Basically, you say, this is what I'm going to query for. This is the rule that I want to read back. And you give it a module, basically your input, your file. You prepare the query for evaluation, which then creates an AST so that you can reuse the same AST for subsequent queries with different inputs. And then you evaluate the input with a particular query and with a particular policy. So that's kind of trivial. One word of warning is that the result set will still require you to do some digging and type assertions before you get the actual result of what you asked for. But it's kind of trivial, and I left it as an exercise to the reader. So a few challenges here. How do we make sure that the customer query actually makes sense? How do we make sure that we're actually asking for something called data.spacelift.result? How do we actually make sure that the customer defines spacelift result? One answer could be, we don't care, because if they don't define, we'll just, explode and it's their fault. That's an option. That's certainly an option. But we can also provide our own kind of piece of code that will define the result with a bunch of defaults. As you can see, this is an object, a JavaScript-like object with a bunch of keys and default values for them. So if a customer then overwrites any of those, the default will stop being used, and the customer will basically affect what result they're getting. And in order to plug it in, we just add it as another module. Ideally, we define it before the customer input, and then we can kind of anchor to it. The second challenge is let's ensure that this decision that they're making is safe. Because by default, fortunately or unfortunately, Rego is not functionally pure. So they have a number of built-ins that allow you to do things like query the environment, or send an HTTP request, or parse extra modules for evaluation. But also, they're aware that this is a potential security risk. So what they did is they allowed you to basically blacklist certain built-ins. And if you're trying to use any of those built-ins, the evaluation will essentially fail. So notice what we consider unsafe. HTTP, sending HTTP requests. Why do you think it would be unsafe? It's not deterministic. Yeah, exactly. Querying runtime. Project sponsored by Cloud Native Computing Foundation, but I think it's currently in the incubator phase. It's already got very considerable following and a number of really interesting integrations. If anyone of you is into Kubernetes, that's what it was created for, so it'll be kind of Kubernetes heavy. But you can also see that it has Envoy policies, Docker policies, Cloudflare, API gateway from AWS, Minio, Ceph, that sort of storage stuff. And I'm using it, in particular, I'm using it for Terraform integration. So I do invite you to do some further research. I hope this talk piqued your interest, especially for those of you who build internal tools or tools that are used by other developers. I invite you to read about it, maybe play. There's a playground at play.openpolicyagent.org where you can provide a rule, provide the input and see how it behaves. And if you want to see it used by a particular application, embedded in an application, you can look up the documentation for my project called Spacelift. It's at docs.spacelift.io, and if you look up the concept of policy, it should be there. Yeah, if you're into infrastructure or Terraform or infrastructure as code, look up my project as well. And if you have questions, you can always ping me your question over email. Do you have any questions now? Yeah.
Guys, any question? Don't be shy. Oh, there's a non-shy guy.
Hey, great presentation. One question regarding the OPA and the rules. You saw the code snippet where we could load data, but as far as I know, OPA distinguishes between the data and input data. And I'm wondering whether the API is also accepting data and input data.
Yes.
You know what I mean?
Yes.
So, or you just merge both and then do the evaluation.
You basically treat all the input, all the user input as what would you want to achieve with
So
Rego?
say who can see invoices, who can do accounting, and
Yes.
so on. Okay.
Yes, it's probably the easiest way of adding those checks, right? And letting them customize it. And I suppose what you could also do is, if people need a UI or UX, you could still have a JavaScript UI UX, right? And then turn it into a policy in the background. So that's also an option.
Okay, great. Thank you very much.
Thank
and
you.
let's have a 10 minutes break.
Thank you.
Cool. So how to make a pizza? But in reality, server send events. So quickly about me, I'm Gopher for 4+ years, open source contributor, and also engineer at Allegro. Here's my website, Twitter, and GitHub. So what is SSE? For me, it's also senior software engineer, but not. Also servers and events. Streaming sim extension. So how many of you knows what is it? Yeah, cool. I think it's also a good topic for next meetup. So if you have any ideas, just pick it up. Also, it's Shanghai Stock Exchange and small scale enterprise. I have no idea what does it mean. And next one, Skyrim Special Edition. Okay, so 20th century, it's about real-time data. So let's look at the example. Okay, so basically we can get any data from server with multiple connections. So basically one connection for one piece of data. But it's not so cool because you all the time for every request you need to fetch some data. Maybe you need to check some authorization. Maybe you need to check if there's something in the cache. So basically you have additional steps which are repeated on every request. But if you have so-called persistent connection, you just initialize something at the beginning and just you can use it as a like kind of in a session. Okay, so different types of real-time data. It can be pull, so it looks like, hey server, do you have something for me? So you're asking from a server. Or it can be push, so server says to all the clients, so hey, I have some data, please pick it up. Another type, it might be bidirectional, so client can say to server, so server and client can communicate in two directions, or unidirectional, or how it's called. So basically previous one also called duplex, as this one I think it's called simplex. Yep, and also different types, but just for a node. So examples. There is a long and short polling. It's, I think, the first idea of real-time data. So for long polling, you just have an open connection, and you're with a big timeout, you're asking for some data until server replies. Or short polling, it's not so popular. I mean, the term, no one uses it, but it's like basic idea. You just quickly asking for data, I don't know, maybe every second, maybe half of a second. So basically you're like DDoSing your server for new data. And also well-known WebSocket. I think it's major player in this topic. Servers and events later. And different types for like MQTT for IoT. So I mean small devices which are kind of hype. And different types because it's, I think I cannot recall all of them. WebSocket. It was made somewhere like 12 years ago. It's bidirectional, so basically server can communicate with you and you can communicate with the server. It's supported by almost all the browsers, even EM. Also, you can send binary data, so basically do not care what you are sending, just like say you're just giving a blob of data and it will be sent to the network. Server events, what is it? As you can see, it's a bit older by 2 years. It's very simple. It's built over HTTP because WebSocket is mostly built like over TCP. I mean, all the protocols based on a TCP. But it's one directional. So basically, only server can send something to client, not via in another direction. And it's not supported by the browsers. I think Internet Explorer is not browser, but come on. Sorry? Yeah, it's Explorer browser. No, just for download your Firefox or Chrome. And there is no binary data. So basically just can encode your binary data into base 64 and you will have the data. I mean like simple text. And debut was in Opera. How many of you remember Opera browser? Yeah. So it's 14 years ago. This was my first year in Technical Lyceum, so it's memorable data for me. So flow of server-sent events. You have a simple endpoint. Suppose it's called SSE. You're making a GET request. You're doing some so-called upgrade procedure. So you are receiving a request. You are checking how you need to treat it and start some communication later. The important thing, you need to respond with a specific content type, which is called text event stream. And basically that's all. You're just pushing your data to your client until your connection is alive. And yeah, so it's pure HTTP. So basically you can add all your checks. Maybe you need to some additional authorization. Maybe you have some delays or how it's called, timeouts and other things. So no magic. So in details, protocol is quite simple. We have ID of each event just to make them unique. So you can compare or you can distinguish which events are when they were sent. Event, it's like type of data of your event. So maybe it's a new mail, maybe it's new notification, maybe some updates. The data, it's like main things that you are sending to your clients. And retry, just how long you need to wait for until this connection will be retried. And basically it's an example of representation of a small event. We have an ID, new line, event name, and some data. Data must be separated by new lines. If you have different, if we have few lines or few blobs of data, and also after last part of the data, we need to make a double new line. So we can distinguish where we have full event and something else. And cause I think in SSE protocol, we have special last event ID header. This header means that what the last ID was received by client. So basically you can know, so maybe one client have read only first 100 messages and next one have read it 110. So you know when you can start synchronize your data with your clients. And I think it's called time. Yeah. So our simple SSE endpoint, how does the upgrade looks like? We are just executing a function upgrade HTTP from our request and response writer. We receive a stream. I will talk about it a bit later. So if we have some error, just return. Simple data, just like for example, and a loop. So just we're in the loop updating our current timestamp, sending it to a stream as a JSON, and sleeping sometime just not to, I don't know, blow up all the network. And yeah, any questions currently? Okay, hope so. Yep. Yeah, great question. The data will be flashed here in write JSON, but all the details will be a bit later, but very good question. So because we have an open connection, we're not seeing specifically when we have end of event and when we need to send this data to our client. So inside this function from SSE library, first thing, we need to hijack our connection. What does it mean? Hijack is a function from HTTP package from standard lib library. It returns a TCP connection, read writer buffer from buff.io, and some error if something happens bad. And basically that's all. This comment is from a documentation, so allows HTTP handler to take over the connection. So as you know, HTTP is based on TCP. So basically we're like making one step to a lower level to have an access for TCP connection. And also very important thing, after hijack we cannot use a request body. So our response body from a request is not usable. We need to work only with buff.io. Okay, So we're at the first step, we're checking, can we make a hijack? So do we have an access? Do our server supports TCP hijacking? And then we are making our hijacking to receive buffer of connection. Then a special function, write response upgrade, in details a bit later, just to make some special response via buffer, and flushing, as you asked. So we are saying that please flush our buffer to our client, so client can understand what is going on, and return our stream. I will also talk about a bit later. So improvise, adopt, and buffer it writer. Some special const. And how does the write response upgrade looks like? It's a simple way to write something in a response in a HTTP protocol. So we just need to answer with a HTTP type of protocol. Currently, SSE supports only HTTP1, so I don't think it's a big problem. And 200 response, so basically everything is okay. We have upgraded. And some additional headers. First one is not so important, but it's okay to add it. And next one important, which means that what is the type of data we are sending to our client back. And HTTP write header looks like we just need to write our header to the connection. Any questions currently? Okay. Stream from a user perspective. So we are returning stream to our user of our API. And what is inside stream? It's basically a read writer buffer and nothing else. We have special function like set event, so we can set event type of our event basically and write it to a buffer. Something a bit less or a bit more low level, just write some blob of data. We just do not care, we're just giving access to user to write something. And different types like set write JSON, write float, or anything you want. So brutal minimalism. It's a really small HTML page to test how it works. I think the important part here is context box. Basically, it will be a box where we are writing our data. And also, I suggest you to Google something like Mother website. It's about creating a simple website in HTML. And yeah, a bit of JavaScript, sorry. We just need to find our context box on our HTML page. We just need to create event source. It's everything included into any browser except Internet Explorer. And we just need to listen to a connection on close. So we will know when our connection will be closed with the server. And next, very important part, to listen to new messages. So basically we know when a new message comes from a server, and just to append it to the contact box. And finger crossed demo. So currently my server works on a local host, and I just can, yeah, it works, cool. So basically I have updated my page to start a new connection. And here we can see that all our data happens here in web console. I think I can increase a bit. So you can see our server just once in a second just sends some data. It's presented as a JSON, but it can be just a simple text as it shown before. I think it works half of a minute and then just dies. Yeah, and where's the Nicholas message as a close? Basically connection is closed. And here we are also adding a close connection as it was before. I mean, showed before. Maybe some questions? No, okay. Yeah, in my demo server, I have a timeout for 30 seconds. And just after 30 seconds, I'm closing connection. but it will be live indefinitely until I decide to close it or clients go offline or some problems with the Wi-Fi. So who needs TCP? Because we have upcoming HTTP 3 protocol, which is based on UDP, which should solve a lot of problems with the mobile networks. But sometimes you can go a bit lower level to a TCP. So main idea, you have better control. So you don't have a lot of things that happens in the HTTP protocol in your server. You just have a pure TCP connection, like pure bytes which goes through network. And also you can see how many allocations do you make, how you are reusing your memory, how much some additional stuff you're making, logging, and so on. And also it's about mechanical sympathy. Idea is to make your code very friendly to your hardware. So if you know how your CPU works or how your memory works, maybe in network, you know how to write code to make it more friendly. So not to reuse, so how to reuse some data, not to create some additional syscalls, and not to just spend time and CPU cycles. I suggest to see two libraries which are very friendly. I mean, friendly for our CPUs and network. First one is fast HTTP. It's a really fast implementation of HTTP protocol in Go. And next one is almost the same, but for WebSockets. Yeah. So let's look how it works. Our simple Go HTTP server. We have just a handler. We have listen file. So basically, we're starting our server here, and really dump handler just writing something in the response like hey and some ASCII art. So how it works inside the server. Here we can see an stdlib server. We just accept some listener, which is a TCP listener. We are accepting a new connection, TCP connections. We're creating some additional context, but we do not care about it. And we are starting a new routine for each connection. So basically for new request, standard HTTP server in stdlib creates a new routine for each request. It might be overkill because if you will calculate it, almost 4 kilobytes per each routine, and maybe it's not your case. As if you have like million connections or you have a small server. And yes, it looks like a simple TCP server. So we have some listener, so TCP listen on this port. We are in a almost infinite loop, accepting new TCP connections and just starting a new routine which handles every connection. And here's cool thing to upgrade. So basically we can go and create our SSE server. We are on a TCP without any HTTP stuff from stdlib because protocol is so simple, we can parse it by our hand. And example, so we have upgrade, which just takes TCP connection. We are creating buffers for it. So basically we would like to read in buffers from a connection. Yeah, we are parsing first line from a buffered reader. We are also parsing a request line, so basically first line of your HTTP request. And doing some additional things like just going through your HTTP request and treating each part as an HTTP protocol. Maybe it's headers, maybe it's some cookies, so basically it's also header. And yeah. So the cool thing, basically that's all. We do not need to make any additional things to create an TCP server by hands because it's really simple. We do not care about anything which is underlined of this writer because we're using buffer writer. And oh yeah, I said that. Where is the code? Libowski. Good question. It's partially available on this link or in this library. I have not pushed everything because I have decided to change my API slightly. It will be published, I promise, and I mean the code. Why Crystal Tech, Crystal HQ, and so on? Basically, a year ago, I have decided to create a better open source. I'm trying to create good libraries for everyone, not from my name, but from like some emergent organization. I really like simple API, so it's easy to use. I'll just copy paste from example and everything works fine. No dependencies, because who need dependencies if you have a small library and you just make a one function or one thing that just works and you don't care what is it colorful output or not. And also I'm trying to learn new things and have fun of doing something which I'm not familiar with, or just I have heard something before. And also it's not a big progress because I would like to sleep sometimes. And yeah, big thanks to Alexander Valyalkin, author of Fast HTTP library, and Sergey Kamartin, author of VS library for WebSockets. Here are the links and question time. Please. No, it's my own idea. Sorry.
Another one. Guys, we need to have one more question. Oh, I see more. That's nice.
Do you know any library for Gene?
For G?
Gene server, the library for.
I think there is one, but I'm not sure.
Okay.
Should be one. I think I saw. I'm not sure. Maybe I saw one for Echo, or maybe for Gene. I'm really not sure.
I have a question about the session, with the cookie HTTP. So HTTP SSE doesn't upgrade your session, doesn't upgrade any cookies. There's no additional request, if I'm understanding it correctly.
No, when you are making a request to a server, you can just send your cookies and you can treat them.
If you hold it for like half an hour and don't make any other request.
Yeah, you just need to make it manually. So no special support. Here before, wait, second. Somewhere here. Oh, exactly. Before upgrade, you can just check your cookies, and you can just set a deadline for your endpoint. So basically, after 30 minutes, you can just close the connection. User will reconnect and will send cookies back, and you will just check them.
And about the reconnection, I'm aware that the original documentation for SSE says that the browser shouldn't make a reconnection, but most of them does. Do you have did you have any problem with that, or did you see that it's kind of changing, or maybe that some browsers do, some browsers doesn't reconnect after the server closes the connection?
To be honest, I don't remember such things. I think it's mostly on a user side, so you need to just code it manually to reconnect. But no, I haven't seen such thing.
Okay, and
Cool thing. I would like to check it later.
And we also had such a problem that since basically this is a normal HTTP connection, in one of our companies on one of the networks, something in between our browser and our server was buffering the server-side events. And I wonder if you ever run into this, that the client was disconnected for a long time, but the server never knew it because some other device was buffering the whole thing.
I heard you need to tweak your proxy. Maybe it's Nginx, maybe something else. So there is a parameter that says you just need to buffer your data, just send it to the user. So maybe some additional load balancers config you need to add it. Thanks.
I got another question. There is something built in the SSE to ensure that all messages was received by a browser, if I understand correctly. But how do you handle, or if it is given the ordering of the messages?
So basically, wait a second. This picture at the beginning about persistent connection. So you have just the same TCP connection, and just while it's alive, you're just sending your data. And there is no ID. You cannot just change the order of your TCP packets. Because TCP packets guarantees that you will order them in, they will be delivered in the order.
A question from me: have you used it with GraphQL? Because when I'm looking at this presentation, the first thing that jumps to my mind is GraphQL subscriptions that are by default using WebSockets, which are bidirectional completely uselessly.
So here is the thing, GraphQL is bidirectional, so you are sending your request through a WebSocket, isn't it? And you
So the whole concept is that in GraphQL you can, for example, send a request for data, but also subscribe to updates to that data. And at that point, like, you're only receiving, you're not sending anything. Have you had any experience with using SSE with GraphQL?
No, I'm not, but if you are just subscribing to some data, so it's easy to use SSE. Yeah, it's basically a replacement until
sense,
you are
right?
not sending your data back to the server via SSE.
Okay, thank you.
I think I have seen one more question here. Okay. Thank you very much, guys.
Thanks.
So that was our last presentation. In 10 minutes, we are going to get beer, and before that, I would like to give you the posters that we received from the Golang community. And thank you very much for joining us, and of course, don't leave